Here we're at Chapter 3, Matter and Energy. Section 3.1 goes over the classification of matter, or in other words, how we can break up matter and classify it, tell properties, stuff like that. Let's go ahead and get started. So, matter. Matter is either going to be a pure substance or a mixture. First, let's adequately define matter. You've learned since middle school, probably maybe earlier, that matter is anything that has mass and takes up space. Now, we can put a little bit of a twist on that, because anything that has mass takes up space, well, that's density. So in other words, all matter has density. If it doesn't have density, it's not matter. So again, matter can be broken up into either a pure substance or a mixture. A pure substance has a fixed or constant composition. Now what that means is that no matter where we find it, it's always structured the same way. So here's an example. Water. Water is always 2 hydrogens and 1 oxygen. If we find a compound, if we find a substance and it has 2 hydrogens and 1 water, or 2 hydrogens and 1 oxygen, it's water. If it doesn't have 2 hydrogens and 1 oxygen, it's not water. So if it's something like this, 1 calcium, 1 carbon, and 3 oxygens, well, that's calcium carbonate, or chalk. So anywhere in the world, or in the universe, that we find 1 calcium, 1 carbon, and 3 oxygens, we have defined that to be calcium carbonate. We say that that's chalk. And that's the idea of the constant or fixed composition. So we're never going to have a situation where it's H3O and say, oh, that's just another form of water. No, it doesn't work that way. So that's a pure substance. Always found, it's always the same, regardless of where it's found. A pure substance can either be an element or a compound. The element is something that's made up of only one type of atom. And these are found in the periodic table. So examples of elements would be sodium. That's an element. Let's say argon gas. That's an element. And then there are some that are a little bit odd, like oxygen gas. It's always found as O2. It's always found in groups of 2. But that's the elemental form of oxygen. There's the elemental form of chlorine, Cl2. But again, they're elements because it's just one atom, one type of atom. A compound is 2 or more elements that are chemically combined. So a compound, your text gives you an example of like sodium chloride. So that's 2 different elements. It's sodium and chlorine together. What's another example? Well, water is another example. Okay. Benzene, that's an example. And then acetic acid. That's an example too. So these are all compounds because it's 2 or more elements that have been combined. Now the difference between an element and a compound, again, both pure substances, but the difference is that a compound can be broken down by chemical means. Now chemical means basically means a chemical reaction. So we're going to take that substance and combine it with something else. And when we combine it with something else, we're able to break that compound down to its elements. So here's sodium chloride. Okay, sodium chloride is NaCl. 1 sodium for every 1 chloride. And we can carry out some chemical process, and we can break this down to the sodium metal, which is reacted with water, and chlorine gas, which is pretty nasty stuff. It'll vigorously attack your lungs and basically make you drown, regardless of where you are. Nasty stuff, used in World War I. So that's a pure substance. Again, it can be an element, can be a compound. An element is only one type of atom. A compound is 2 or more elements that are chemically combined. Now, contrast that to a mixture. A mixture is 2 or more different substances, and they are physically mixed, but it's not the same proportion every time. A good example that I like to give is soda. So here's your glass of soda. Right? Now, let's say you take 1 drink of soda, and then a half hour later you come back and take a drink of that same soda. It will not taste the same. The reason why is because that soda is a mixture. That soda has carbon dioxide dissolved in it. And as you let it sit, that carbon dioxide comes out of solution. The carbonic acid, which is what the carbon dioxide forms whenever it's dissolved into the solution, the carbonic acid breaks down to water and carbon dioxide. The carbon dioxide gas leaves. So that's one example of a mixture. Another example of a mixture is, let's just say, a salad. That's sort of the classic example. I'm drawing a salad as if you've never seen one. So here's a salad of some sort. But it's never the same twice. Okay, so it can be something different every time. Now with mixtures, it's either homogeneous or heterogeneous. A homogeneous mixture is uniform throughout. Okay, so for example, let's say salt water. You take a little bit of water. So here's your glass. You take a little bit of water. That's the date. Take a little bit of water, and then you throw some sodium chloride in there. So here's your salt, table salt. Right? Throw it in there. You mix it up thoroughly. Now that entire solution is the same. So it's a mixture, and it's a mixture because anytime I make sodium chloride water, salt water, it may not necessarily be the same, but it's also a mixture because I can easily separate them. So I can allow that water to evaporate out, and that'll leave my sodium chloride behind. And that's not a chemical process, that's a physical process. So that's a homogeneous mixture. A heterogeneous mixture then is not the same throughout. Okay, there's 2 different layers. So a real easy example of this would be like oil and water. You know, when you mix oil and water, you get 2 different layers. So that would be a heterogeneous mixture. Each one of these layers is called a phase. Not incredibly important, but just to let you know. So again, we can break down mixtures by physical means. Physical means could be just filtration, could be boiling, distillation, could be fractional crystallization, which is basically using the freezing points of 2 different substances. So here for this oil and water, let's pretend that I drop it down to 0 degrees Celsius. Well, that water is going to freeze, but the oil is not. And then I could filter that off potentially, and I would have an oil layer and a water layer, water in the form of ice. Okay? And that's it.